salary of government employees on the general schedule is $59,593. The average salary of 30 state employees who do a similar work is $58,800, with sigma equals $1,500. At alpha equals zero point zero 0.01 level of significance, can it be concluded that the state employees earn on average less than the federal employees? So let's take a look at our 5-step process on our hypothesis testing. And let's just note that step 1 is to state the null and alternative hypothesis. So for step 1, let's just note that from this part right here, we have the fact that can it be concluded that state employees earn on average less than federal employees? Since this is a statement of difference, we know that this is going to be the alternative hypothesis. So the alternative hypothesis is that mu is less than $59,593, and the null hypothesis is always in the form mu equals $59,593. So Step 2 is to compute the appropriate test statistic. So here we need to discern whether we need to compute the z-test statistic or the t-test statistic. So to determine that, we notice that sigma right here is given, and the fact, since we don't have anything about normality, but we do have the fact that the sample size is 30, so we are in a large sample size case, so we have at least approximate normality by the central limit theorem. So we can use the z-test statistic. So the z-test statistic is in the form x bar minus mu under the null times the square root of n divided by sigma. So here we're going to get x bar, which came out to be 58,800, minus mu under the null hypothesis, and mu under the null hypothesis is 59,593 divided by the square root of 30 divided by sigma, which we are told is 1,500. So coming over here to our handy dandy calculator, we can type in open bracket 58800 minus 59,593 times the square root of 30, and then divide that by 1,500. So here we get about negative 2.9. So our z-test statistic is equal to negative 2.9. So step 3 here is to compute the p-value. So we can sketch a standard normal distribution, and note that the type of test is determined by the alternative. So we have a left-tailed test, so negative 2.90. So we will shade this region, and let's just note that this is our p-value. And we can compute that since we have the z-test statistic using the normal CDF. Lower bound is negative infinity, so negative E99 all the way up to negative 2.90. So we can come over here to our calculator and right here our distribution. So second distribution, menu option 2, normal CDF, negative E99, comma, negative 2.9. So we get about 0.002. So step 4 is our decision-making process. This is where we either reject or fail to reject the null hypothesis, and then make sure we state our reason why. So here our p-value is 0.002, and we want to compare that to our alpha level, which is 0.01. So let's just note 0.01, 0.01. So notice that 0.002 is way smaller than 0.01, so our decision is to reject the null hypothesis. So here all we're saying is that there appears to be enough evidence in the data in support of the alternative hypothesis, so we will go ahead and reject the null hypothesis based on what the data is telling us. So step 5, to summarize our results, since we're rejecting the null hypothesis, we could just come back and say at alpha equals 0.01, the data indicates that the mean salary of state employees is less than $59,593. And since that p-value is 0.002, this indicates strong evidence in support of the alternative hypothesis. So the idea of committing a type 1 error is very, very small. So we don't really have to concern ourselves with that. Okay, I hope that helps.